Hi, this is javinkharod, a chemical engineer by profession, going to continue our today's topic, cracking. Now, what is that? In response, how to make use of behavior hydrocarbon stream to increases the amount of gasoline range product available. Several cracking techniques were developed. The most popular technique, catalytic cracking, also called cat cracking. Now, cracking is the integral part of oil refinery. Crude oil is the refined using method called fractional distillation. With this method, crude oil is divided into several fractions based on boiling point of its constituent molecule. The fractions are heavy gas oil, lubricating oil, gas oil, diesel, kerosene, gasoline, naphtha, and gases. In that order, length and arrangement of molecule vary as a result. They display various characteristics include boiling point. Now, the separation fraction can undergo additional processing, yield a variety product needed every day, such as fuel, polymer, and medication. Now, cracking can be defined the process use oil refinery to break down large and complex hydrocarbon molecule into lighter, smaller hydrocarbon. They are better suited to industrial or consumer uses. The crucible step in the refinement of the crude oil is cracking. Now, cracking is done the breaking all carbon-carbon single bond present in long chain hydrocarbon and usually produce smaller alkane and alkenes. The product may vary depending on temperature and catalyst. All through higher temperature very essential. The first and most important step refining process is fragment or crack the unprocessed hydrocarbon molecule into smaller part in order to assist transform the crude oil into form that can more extensively utilize. The process known cracking enable the conversion of crude oil into range commercially viable fuel, lubricant and other goods. Cracking is a process in which large hydrocarbon molecule broken crack into smaller, more valuable hydrocarbon molecule. As the name implies, the catalytic cracking process takes place in presence of catalyst. The catalyst promote breaking of large molecule certain way that maximum yield of gasoline. Ideally, all catalytic cracker produce would be the gasoline range, but the technology is not that capable. Catalytic cracking produce a full range of hydrocarbon from methane to residue. The feed, the catalytic cracking, typical gas oil or naphtha. The trend and design of modern cracking unit is the ability to include the residue part of the crack feed. The residue produced by catalytic cracker recycle back into feed stream. The recycle of the residue called recycling extinction. The catalytic cracker and cracking consists three major processes that are reaction, regeneration, and fractionation. In the reaction step, the hydrocarbon feed is contacted by the catalyst at a higher temperature, means 900 degree Fahrenheit and 482 degrees centigrade, and cracking reaction take place. During cracking, coke is formed. The coke will coat and catalyst prevent it from the promoting cracking reaction. The catalyst is renewed by burning of coke deposit from the catalyst surface during regeneration. The cracked hydrocarbons are separated using conventional fractionating equipment. Now, there are basic type of catalytic cracker. They are fluid bed, moving bed, fixed bed. The name of catalytic cracker style describes catalyst bed. Use fluid bed catalytic cracking is the most popular design in use today. The SCC unit, the catalyst is finally divided powder, then catalyst is fluidized or fulfilled up with air or hydrocarbon vapor. It's behave like a fluid and can be moved through pipe and pipes. The catalyst in a moving bed catalytic cracker in the form of bed or pellet or mechanical mean must be used to move catalyst from one part of process to another. The newer plant air, lift air or combustion gases from the catalyst regeneration are used to move catalyst from one place to another. In fluid catalytic cracking, the moving bed cracking catalyst is regenerated in area separate from the reaction. The catalyst has to move some means from the reactor and regeneration area. In fixed bed design, the catalyst is not moved. The equipment consists series of reactor vessels contain catalyst bed. Some of the reactor will be online producing cracked hydrocarbon while other will be off time having catalyst regenerated. The name of catalytic cracking style describe catalyst bed use. Fluid bed catalytic cracking is the most popular design. FCC unit. The catalyst is finely divided powder and catalyst fluidized with air and hydrocarbon vapor. Its behave fluid. It can be moved through pipe and path. The catalyst moving bed catalytic cracking form of bed or pellet or mechanical mean must be used to move catalyst from one part of process to other. A newer plant air, lift air and combustion gases from the catalyst regeneration are used to move catalyst from one place to another. In FCC and moving bed cracking, catalyst is regenerated area separate from the reaction. The catalyst has moved by some means from the reactor and regeneration area. In fixed bed design, catalyst is not moved. Equipment consists series reactor vessel contain the catalyst bed. Some of the reactor will be online producing cracked hydrocarbon while other will be offline having catalyst regenerated. Most of fluid catalytic cracking unit can be described being one of the general design, a stack design, a side-by-side design, or riser reactor design. The term stack and side-by-side refer relationship reactor to the regenerator. In the riser reactor design, there are no reactor vessel in the conventional sense. The cracking reaction takes place pipe which connect with the regenerated catalyst storage area and the catalyst hydrocarbon separation equipment. The process-based continuous circulation catalyst between reactor and regenerator. The regenerated catalyst flow from the regenerated standpipe into bottom of reactor long radius U pipe. The hydrocarbon feed is introduced. Catalyst flow in the U pipe. Heat causes feed to expand and vaporize fluid the catalyst. The catalyst and hydrocarbon feed then enter reactor where the cracking reaction are completed. In practice, most of the cracking hydrocarbon accomplish U pipe prior entering the reactor. The cracked hydrocarbon are separated catalyst, cyclone separator. They are internal to the reactor. When charged the fractionating column, the hydrocarbon are separated in the various stream in the fractionator. The fractionator bottom non-cyclable, they are reintroduced in the feed stream and recycle the extinction. The spent catalysts, they are coated with coke gravity flow to steam stripping section located below the reactor. In the steam stripper, residue hydrocarbon are removed from the catalyst. After the steam stripping, the catalyst is refluidized by auxiliary air and forced into regenerator. The combustion air is introduced in the regenerator and coke is burned off the catalyst. The combustion gases exit top of the regenerator after passing cyclone separator. To remove the catalyst fumes, the combustion gases are used to fuel the steam generation in carbon monoxide boiler. The regenerated catalyst enter the standpipe in the bottom the regenerator using recycle bag to the reactor. Now, type of fouling. The operational deposit hydrocarbon site cracking unit, typically a mixture of organic and inorganic material, consists iron, sulfate and sulfide. The consistency of the deposit range, hard coke-like material. What can be described? Sludge. The coke deposit usually found heat exchanger bundle in cycle line between bottom of fractionator and the reactor. Coke deposit may also found feed stream, preheat furnace, hydroblasting. Properly the most effective mean remove the coke. No solvent system has found the effective remove the coke. The fouling on water side heat exchanger will be primary waterborne scald and corrosion product. Depending on water source, there are many techniques chemical removal. This type deposit are effective, efficient and cost tolerant. The air side fin fan cooler will become fouled with stool-like coating ordinary dirt and type of fouling can usually be removed spray washing. Hot natural detergent based solution contain a suitable surfactants. The boiler will become fouled with same type of deposit can be found in convectional boiler and waste heat boiler. They are susceptible to fouling by operational deposit. The unit must be periodically cleaned just like any other type of boiler. Now lube and seal oil systems, they are very important in cracking system. In addition to the use pump and boiler, this will be large system, air compressor and cyclone separator. They are typically thousands of gallons in the system volume. While the system do not require be clean often, they are occasionally cleaned. Cleaning can be accomplished process typical proportional cleaning technique on interest because of extensive amount of temporary piping that is required from circulation loop, vapor phase cleaning and appropriate chemical additive good candidate for the cleaning process. Now fractionator and associated equipment will contain fouling similar that found the crude plant distillation process. The column will require hazardous vapor removal, light and hydrocarbon, such benzene and de-oiling additional since catalytic reaction and FCC unit result formation unsaturated compound encounter lower molecular white polymer and varnishes deposit inside fractionator and heat exchange equipment. Lastly, fluid catalytic cracking unit, also Nestle vessel called slurry settle tank. This vessel collects catalyst fins from suspended slurry oil. From the process, the separated slurry oil is decanted top of the vessel, reused while the catalyst fins precipitate inside the slurry tank, forming a hard, concentrated like solid. The catalyst solid are impregnated with the hydrocarbon that take catalyst fins hazardous waste that carries the hazardous waste code and material is expensive to dispose. Now recent development in the extraction chemistry, the resulted process, chemical product, they are extensively removed part per million level of numerous constituent. The compromises K code and allow non-hazardous disposal of the spent catalyst fins through conventional non-hazard waste disposal facility. Imagine the saving the gained non-hazardous disposal. Now, cracking importance. Why it is important? It is beneficial to maintain supply and demand fraction of the fuel present day world due to high fuel efficiency, lower carbon chain hydrocarbon. It is important crack down long chain hydrocarbon obtained refinery during fractional distillation and produce effective fuel. How much percentage of oil refinery produce supply, how much portion the consume want to purchase a demand. In the most cases, fractional distillation crude oil resulted lower quality of the smaller hydrocarbon that consumer want, the more of the larger hydrocarbon that can be sought. Gasoline is the another smaller hydrocarbon work better fuel than the larger hydrocarbon do. The availability of the fuel is increases because of cracking breakdown hydrocarbon into smaller one, aid in balancing supply and demand. Another important of the cracking production multidimensionally utilizable alkane and resulted alkane compared to alkene. Alkanes are more reactive. They serve raw material, petrochemical sector for the making various polymer, plastic, etc. Now, use of the cracking. The many significant compounds are the made from the cracking byproduct such as ethane, propane, buta, 1,3-diene and C4-alkanes. To increase this octane rating, additional compounds such as branch and cyclic alkane are add gasoline fraction left over the distillation crude oil. Okay guys, this is up to today's our topic cracking. I hope you get sufficient knowledge after watching this video. Next chapter, we have covered some another chemical engineering topic. Still then, goodbye. Do take good care of yourself and wishes you a very happy Sunday.